solving an absolute value inequality problem type 1. So at this point, you should have already seen inequalities and absolute value equations, and now we're going to combine the two. So if you saw something like this, the absolute value of W is less than or equal to 2. Let's kind of think about what's happening here. We're trying to find values for W that we could plug in here and make this a true statement. Now, if I plugged in, let's say, 1 for W, the absolute value of 1 less than or equal to 2, question mark. 1 is less than or equal to 2, so that's good. So we want 1 to be in our solution. And even if there were a negative 1 in here, this would just turn positive because the absolute value of a negative just makes it positive, and that 1 would fit in there. Now, if you think about the numbers that are going to work, we could go up to 2 or negative 2. So if we put negative 2 in, we're going to get the absolute value of negative 2 is positive 2, and that one works. So negative 2 is going to work, positive 2 is going to work. But if I put in anything outside of that, or anything bigger or smaller, so like the absolute value of, let's say, negative 5, less than or equal to 2, then I would get 5 is less than or equal to 2, and that's not a truth statement. So the values that are going to work are going to range between negative 2 and 2. And one way we can write that is with what I've just written here is called a compound inequality. So this guy right here says that W on the low end can be negative 2 and on the high end can be positive 2. So keep in mind that we did this with a less than or equal to sign. We did it with a less than sign. And let's think about what would happen if we had something different. Like, let's say the absolute value of X is greater than or equal to 5. Now, when I go to plug numbers in, let's try plugging in 1 or negative 1 even. So we plug in negative 1. Greater than or equal to 5, question mark? 1 greater than or equal to 5. That's not true. Negative 1's not going to work. And likewise, positive 1 won't work either. If you start to think about the numbers that are going to work, the numbers that you could plug in for X and make a true statement, on the positive side, they're going to have to be greater than or equal to 5, right? Those are the only positive numbers that are going to work. Something like 6, greater than or equal to 5. Ooh. Let's see, undo. Greater than or equal to 5. 6 is greater than or equal to 5, so 6 is going to work. Negative 6 is going to have that same effect. So 6 and negative 6 work. Basically, anything that's greater than or equal to 5, that's going to work. Or anything that's less than or equal to negative 5 will work. So negative 6, negative 7, negative 8, negative 9.253, anything that's less than negative 5 will work, and anything greater than positive 5 will work. So in general, we have a few rules. If you have that the absolute value is less than or equal to, so the underlined part doesn't matter. It could be there, it could not be there. Same rule, just the direction that matters. And I'm just going to choose a number. Let's choose 7. 7's a good number. If you have that the absolute value is less than a number, the way that you deal with this is you sandwich it between negative 7 and positive 7. So whatever this number is right here, you on the low end have this number negative, so that's right there, and on the high end have the positive number, and X can be anything between those two numbers. If, on the other hand, you have a greater than or equal to, so once again, this underline right here can be there or not. If you have that it's greater than 7, this actually splits into two inequalities. The first one is as if you just erased these lines right here. So imagine if I just came in there, I can't make my eraser smaller, so I would ruin everything, but imagine coming in there and just erasing these lines. You would have X is greater than or equal to 7, and then you want to make sure you get all those negative numbers. Remember, back here, these negative, my pointer, these negative numbers, you want to make sure you get those ones as well, right? Positive 6 works here, and so does negative 6. The way that you grab that, you'll do X, and then less than or equal to the negative of this number right here. So negative 7. So flip the direction, negative 7. This works if you have positive numbers. There's some weird stuff that can happen with negative numbers. If you have the absolute value being less than or equal to some negative number, like let's say absolute value of x is less than or equal to, or even just less than, doesn't matter, -4. Absolute values are going to give you positive numbers only. And if this guy over here is positive, it can't ever be less than a negative. So in the situation where you have an absolute value less than a negative number, this is going to be a no solution situation. On the other hand, if you have the absolute value is greater than or equal to a negative number, right? Something like the absolute value of x is greater than -4. All positive numbers, which this guy over here will be positive, all positive numbers are greater than all negative numbers. So no matter what you plug in for x, you're always going to get a true statement here. So this guy would be all real numbers. So let's go ahead and try out a few examples here. So here we have the absolute value of u is greater than 6. Once again, if it's a greater than sign, it's going to split up into two inequalities. The first one is as if those lines are not there. So u greater than 6. For the second one, you flip the direction, so it was pointing to the right, it's now pointing to the left, and make the number negative, and the little word or in here. On Alex, just so you're forewarned, they're going to ask you to answer like this, right? I have put some additional instructions in here so that we can practice what you're going to be asked to do on the exam, because this is not the part we're looking for on the exam. We're going to be looking for your interval notation as well as a graph on the number line. So, this topic actually, you don't have to input it like this. It's a different topic, you input it like this. This one, you're just doing the number line. In later topics, they're going to ask you to enter it just like this. But on this topic, it's just the number line, but I'm going to talk about interval notation as well. So, number line first, I just need to label the two numbers I'm interested in, which are 6 and -6. For -6, pointer, there's no underlines on either of these, right? If this one doesn't have an underline, neither of these ones will. So on -6 and +6, I am putting open circles. And then the numbers that are less than -6 are these guys over here. And the numbers that are greater than +6 are these numbers here. The way that we would write this in interval notation, remember negative infinity is out here, positive infinity over here, would be negative infinity to -6, union 6 to infinity. So when you end up with a greater than sign here and an absolute value, it's really, really important that you internalize that this is only when you see these up and down lines. If you do not see up and down lines, you are not splitting. You are not sandwiching. You only sandwich or split when you have these up or down lines. So when it's this greater than sign, it splits into two. When it's a less than sign, it turns into one inequality. And I like to remember that, and this is silly, but 1 is less than 2. So one inequality, inequality is less than 2 inequalities. And that means that if you have 1, which is less than 2, right, you use the less than, so it turns into just one giant inequality. And if you have a greater than sign, because 2 is greater than 1, it splits to 2. So greater than is 2, less than is 1 sandwich here. All right, let's look at another one. So here, when you have a negative on the other side, remember, there's two things that can happen. Either this is going to turn out to be an all real numbers answer, or it's going to be no solution. And it all depends on the direction that this guy is pointed. In this case, we have a less than sign, so we're asking for positive numbers to be less than a negative number, and that just can't happen. So there would be no solution here. We can't graph it on a number line. We can't give an interval notation. There's just no solution to this at all. For one last example, here we have the absolute value of x is less than or equal to 13. If it's a less than sign, this is where you're going to sandwich. You're going to make one inequality, and it's going to be 3 pieces long, starting with the negative version of 13. So negative 13, less than or equal to. So if this guy has an underline, this guy will have an underline here. Put the variable in the middle, x, less than or equal to this positive number here. You're just taking x, or taking whatever's inside here, and sandwiching it between the negative version of this and the positive version. So negative 13, 13. And if I draw a number line, negative 13, positive 13, because we have underlines here, I'm going to go ahead and draw closed circles. And then the sandwich part means that x is between them, so you're shading that middle portion. As an interval, this is the interval negative 13 to positive 13. And that's all you need to know for this particular topic. In a little while, probably pretty soon for you, you'll be looking at some slightly more difficult problems, but this is the basics of what you need to know about absolute value inequalities. Keep on doing what you're doing a great job. I will see you in another video.